Hello everyone, welcome to Digital Electronics and Computer Organization course. I am Sudhakar Ajmera, Assistant Professor, Department of EC, MLR Institute of Technology, Hyderabad. We'll see today what is the logic gates and classification of logic gates. Now let us move on to what do you mean by logic gate. Digital logic gates are the basic building blocks of digital electronics and computer systems. These are used to design computer architectures or computer digital circuits, and they are the electronic components which are used in digital circuits, which will work based on input signals and perform logical operations and produces the outputs based on our operation or the inputs. Then we will classify primarily logic gates are as below types. One is basic logic gate, another one is special logic gates, and one more is universal logic gates. So logic gates are primarily classified into three types: basic logic gates, special logic gates, and universal logic gates. Today we discuss about this basic logic gates and special logic gates. In next class, we will see universal logic gates and all logic gates applications, where we can apply all these logic gates as a part 2. Now let us move on to basic logic gates. What do you mean by this? So these are basic logic gates and or not are considered to be basic building blocks of digital logics, because they can be combinedly used to create all other logic gates and digital circuits. That is why and or not, these three are known as basic logic gates. Let us discuss about all these logic gates in detail. First one is AND logic gate. So AND logic gate symbol is this one. So it is for two input AND logic gate. Here A and B are inputs and Y is the output. Here I can give n number of inputs and it will produces only one output. So what I mean to say, any logic gate will accept n number of inputs, not only two inputs, it can accept n number of inputs and produces one output. But for the simplicity, I have taken here only two inputs as A and B. This is the logic gate symbol and operator of logic gate, logical operator is this one, which is used to perform generally multiplication between variables. Here I took A comma B as the input. These two are multiplied and produces Y output. This is what AND logic gate will do. So let us see truth table of AND logic gate. Is truth table consists of possible number of inputs and produces output. Here I have taken only two inputs A and B and Y is the output. With this two input, I will have four possibilities, that is 0, 0, 0, 1, 1, 0, 1, 1. As I said, this AND logic gate is used for multiplying the variables or the logics. So here according to this, 0.0 will produces 0 for this combination, and 0.1 here A is 0, B is 1. If I multiply this, I will get 0, and here 1.0 output is 0, and here 1.1 output is 1. So based on these inputs, I will have these outputs. So for 0 and 0, what output I will get it as 0. For 0 and 1, I will get it as 0. 1 and 0, I will get 0. 1 and 1, I will get 1. So based on these inputs, I can say for AND gate, if any one of the input is 0, I will get output as 0, that is low. If both the inputs are high or 1, then only I can get 1. This is what definition of AND logic gate. Now let us move on to OR logic gate. So logical symbol is this one. So here I am taking only two inputs. It's a 2 input OR gate, and Y is the output. So it is used for addition of the logics, and symbol logical operator is this one, which is used for addition of logic. Let us see truth table of OR logic gate is, which has inputs and has output. For simplicity, I have taken only 2 inputs, which will produce as Y is the output. So with these 2 inputs, I will have 4 possibilities, that is 0, 0, 0, 1, 1, 0, 1, 1. Now let us see based on this 0 plus 0, A is 0, B is 0. If I substitute this in this expression, I will get 0. 0 plus 1 for this combination, I will get 1. 1 plus 0, I will get 1. 1 plus 1, I will get 1. So if you observe here, for Boolean algebra, 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 1. In linear algebra, 1 plus 1 is 2, but here in Boolean algebra, 1 plus 1 is nothing but 1 only. So based on this inputs, I got these are the outputs. So here, if we observe, if any of the input is 1, I got output as 1. And in rest of this case, like if both the inputs are 0, then only I will get 0 is the output. So this is what OR logic gate defines. Next, NOT logic gate. It is also known as inverter. Logical symbol for NOT logic gate is this one. So here just now I said any logic gate will have n number of inputs and produces only one output. But for NOT logic gate, it will accept only one input and produces one output. Here let us assume variable as A, this is the input and produces Y is the output. So as I said, it is used as a inverter. What it will do? It will do complement of the input. So here if I have A input, I will get A bar here. So what I mean to say, as per this logic symbol, if I have 0 input, which will produce as 1 output. if I have one input, it will produce a 0 output. So here 0 will be inverted or complemented, 1 will be inverted or complemented. Now logical operator of NOT gate is this one. This is the logical operator, or I can use this one. Now let us see truth table of NOT logic gate, which has input and output. It has only one input. Let us say input is A, output is Y, which will do its complement. So with the help of only one input, I will get two outputs. So that is, if I have 0, I will get 0 bar, that is 1. If I have one input, one complement is 0. So what I mean to say, 0 will be inverted like 1, or 1 will be inverted like 0. So if I give 0, I will get 1 output. If I give 1 input, I will get 0 output. So what it is doing? It is just complementing. That is why it is known as what? Inverter. Now let us move on to exclusive logic gates. So logic gates, these two are known as XOR and XNOR, or known as exclusive logic gates, which are used for producing exclusive operations. So exclusive logic gates are a type of digital logic gates that produces an output based on whether the inputs are same or different. So let us discuss about one by one. XOR logic gate, also known as exclusive logic gate. So here if you see logical symbol of XOR gate is this one. For simplicity, I have taken only two inputs and produces one output. That is A XOR B. So here logical operator I will use for XOR gate is this one plus N circle. So if you expand this, A bar B plus AB bar. So this is the expression for XOR gate. Let us see truth table of XOR gate. So here XOR gate has inputs and output. For simplicity, I took only two variables A and B and produces Y output. That is nothing but A XOR B. If I expand this A XOR B, I will get this one. So with these two inputs, I will have four possible combinations, that is 0 0, 0 1, 1 0, 1 1. And if you substitute this 0 0 in this expression, so here A bar, here A and B are 0 0. If I substitute in this one, the 0 bar dot 0 plus 0 dot 0 bar. So what I mean to say here, 0 bar become 1 dot 0 plus 0 dot 1. If I multiply this, 1 dot 0 is 0 plus 0 dot 1 is also 0. If I add this 0 plus 0, I will get 0. So finally, I will get it here A XOR B is 0 for this combination. And likewise, if I substitute this 0 and 1 in this expression, so A is 0 and B is 1 plus A is 0 and B is 1. So 0 complement is 1 dot 1 plus 0 dot 0. What I will get? 1 plus 0. So 1 plus 0 is nothing but 1. For this combination, I got 1. Likewise, if you substitute this 1 and 0, so 1 bar dot 0 plus 1 dot 0 bar. So 1 bar is 0 dot 0. For 1 dot 0 bar means 1. So this is nothing but 0 plus 1. So 0 plus 1 is 1. For this combination I got 1. So for 1 and 1, for next combination we'll see, if you substitute this in this expression, so 1 bar dot 1 plus 1 dot 1 bar. So 1 bar is nothing but 0 dot 1 plus 1 dot 0. So 0 dot 1 is nothing but 0 plus 1 dot 0 is also 0. If I add 0 plus 0, I will get 0. So what I want to say, for 1 and 1 combination, I got 0. So this is what the truth table of, XOR gate. What we have observed here it is, when both the inputs are same, that is either 0 0 or 1 1, output is 0. The rest of all other cases, so what I mean to say, the inputs are not same, that is 0 1 or 1 0, I got 1. So that is why exclusive logic gates are a type of digital logic gates that produces an output based on whether the inputs are same or different. Here you can observe those. So here inputs are same, that is 0 0 or 1 1, output is 0. When inputs are different, that is 0 1 or 1 0, output is 1 1. So let us see about XNOR gate. Logical symbol for XNOR gate is this one. It is actually, XNOR gate is nothing but XOR gate plus NOT gate. If we add to XOR gate, NOT gate, we will get XNOR gate. So XNOR gate is nothing but, it's a inversion of XOR gate only. If you do complement of XOR gate, we will get XNOR operation. So that is why we have to add XOR gate to NOT gate, then only we can get XNOR gate. So for simplicity, I have taken two inputs for XNOR gate, that is A and B, and which will produce only one output. Here logical operator for XNOR gate is this one, dot encircle. So if you expand this, I will get A dot B plus A bar dot B bar. So this is the expression for XNOR gate. Now let us see truth table of XNOR gate, which has inputs and output. So for simplicity, I have taken only two inputs, that is A and B, which will produce as Y is equal to A XNOR B, that is A dot B plus A bar B bar. So with these two inputs, I will have four possibilities. With these two inputs, I will have four possibilities. That is, with A and B, I will have four possibilities. That is 0 0 or 0 1 or 1 0 or 1 1. If you substitute this 0 0 in this expression, let us see 0 dot 0. A is 0, B is 0. So 0 bar dot 0 bar. What I will get? 0 plus 0 bar is 1. Again 0 bar is 1. So what I got? 0 plus 1 is nothing but 1. So for 0 0 combination, I got 1 here. The same way, if you substitute 0 and 1 as A and B in this expression, so 0 dot 1 plus 0 bar dot 1 bar. So 0 dot 1 is 0 plus 1, 0 bar is 1 dot 1 bar is 0. So this is nothing but 0 plus 0. If I add 0 plus 0, I'll get 0. So what I mean to say, for 0 and 1 combination, I got 0. Likewise, if you substitute 1 and 0 in this expression, so let us see 1 dot 0 plus 1 bar dot 0 bar. So 1 dot 0 is nothing but 0 plus 1 bar is 1 dot, this is what? 0 bar is nothing but 1. Sorry. Here if you observe, if you substitute this 1 and 0 in this expression, if you substitute this 1 and 0 in this expression, I'll get 1 dot 0 plus 1 bar dot 0 bar. So 1 dot 0 is nothing but 0 plus 1 bar is 0 dot 0 bar is 1. So this is nothing but 0 plus 0. I'll get 0. So for 1 and 0 combination, I got 0. The same way, if we substitute 1 and 1 in this expression, let me see 1 dot 1 plus 1 bar dot 1 bar. So 1 dot 1 is 1 plus 1 bar dot 1 bar is 0 dot 0. This is nothing but 1 plus 0. So 1 plus 0 is nothing but 1 only. So what I mean to say, for 1 and 1 combination, your output is 1. Here from the truth table, if we observe, if both the inputs are same, that is 0 0 or 1 1, your output is 1. And if inputs are not same, that is 0 and 1 or 1 and 0, output is 0. It is exactly inverse of XOR gate. So how I got it? If we invert this XOR gate by adding NOT gate, I can get XNOR gate. This is how I can get XNOR operation. So we have discussed about what is logic gates and their classification. In next session, we'll see universal logic gates and applications of logic gates. As a part 2. Thank you.